What's up, guys? Welcome to another stream where I'm gonna try to learn math. Uh, this shit is difficult, bro. I mean, it's not difficult, but it's just like Greek right now. Cause I had no idea what these like symbols mean. So this is apparently like the summation. This bullshit. So I learned this formula. It was the variance formula, right? So it's like the mean. I usually like doing shit in like a wait. The fuck? Canva drop. Sorry, I'm just very sick right now. But so basically, what I try to do here is, say for example, first of all, you find the mean, right? So obviously, I like drawing shit. Makes me remember easy. First, you find the mean, and then you find the difference of each value. So I'm just gonna call it each value, and then you divide this by the mean. I think, yeah. And once you divide this by the mean, you now have so once you do this, I'm pretty sure you can just I don't think you need to divide it by the mean. No, you just do this second value, tie it to the power 2, so it's a second to the power 2. So let's just say like that. The second one is in, just this basically to the power 2, and that's gonna give you the variance. If you get the square root of this, that's the standard deviation. Now, standard deviation comes from day trading itself, but it's not the same standard deviation, not exactly at least. So with my camera, bro, is it fine? Standard deviation. So this is you can use like certain packages, like there was this one, I think it was math.std, I'm not too sure, and you can just give it the variance, right? So yeah, it's not a big deal there. Basic slopes are basically, y2 minus y1 divided by x2 minus x1, right? So this is basic slopes. Yeah, so apart from that, what else do we have? This is the mean. So apparently this thing means like the mean, like everything combined. I had like one example on this. There was like an example. Basically, it's the mean value. So if there's this, that means it's like the mean value. What else do we have? So essentially, this means each value in x. X is like an array of data. Each value in x, so it's like, iterate into it, and then this is the mean value. So essentially, in variance, like how I said, the first method is to find this, and let's say mean, and then you divide the mean by each value. So I'm just gonna call it each value minus we'll just call this mean value, and you divide it by, sorry, you reduce this by the mean value, and then once you reduce this by the mean value, right? So let's just say let's just call it FC or something, I don't know. So FC to the power 2. So that's basically the variance. So I'm just gonna call it var, and then var divided by the square root of var is basically the STD, which is standard deviation, isn't it? So standard deviation is obviously I don't exactly get where this applies, but yeah. So obviously this is the summation, so that's what this is used for. This is the average, this is each value, this is each x value, and this is the average, the whole point of variance, pretty much. So this is summation, like the combining all them together. See? So yeah, so that's pretty much as far as, I want to increase this a bit. So that's pretty much as far as summation. So obviously mean has this, so I'm just gonna remember this U-turn symbol or the X bar. Variance, so obviously I have variance. Variance apparently is used it's used like this. So that's what we, got here. Oh fuck. That's what we got here. Okay, so that's what we got here. So apart from that, we have the standard deviation. So these are the symbols for those. And slopes, which is m. So apparently you're supposed to use like I think intercept times x and So I think it's like slope times times x plus intercept, something like that. Let me try. Slope times x plus intercept. Is that correct? Okay, that's the equation of a straight line. So, okay, so slope is m, x is basically the x value, and independent variable, okay, that's the input, there we go, and intercept is basically the y, where the line crosses the y-axis, okay. Cool, so that's the equation of a straight line, okay. Okay, that's interesting. So I like learning like this, you know, getting screenshots, drawing is my way of learning, you know what I mean? So yeah, this is the output, obviously, and this is the slope, and this is the input, and this is the intercept. So where the line crosses the y-axis, okay. Okay. Just call it math intercepts. Cool. What else do I need to know? Trying to like learn this shit. You can use like .car for this, right? It creates like this oh, my Spotify's tweaking. Pretty sure you can just do .car. Where can I do .car? What does .car do? I'm pretty sure it's like a correlation matrix. What else do we have here? Okay. Interesting. Yeah, so it's a correlation matrix, that's what it is. So a correlation matrix basically, as far as I've seen, it sort of calculates, wait, I saw that somewhere. I think it was this one. So correlation coefficient, so yeah, so if it's far away, I'm pretty sure like -1 means like it's negative, and okay, so 0 means there's no relationship, and positive means there's positive linear relationship. Okay, so I don't exactly get this, so I'm just gonna try. So if it's positive correlation, and it's, wait, what? Let me just be like, I don't exactly understand negative and positive. What the fuck? Correlation. Can you summarize and simplify it for me? One sec. Okay, so it seems like okay, so positive, which where one variable goes up, the other way. Okay. Okay. It doesn't go up, okay. This is linear. Q time go down, okay. Okay, cool. Yeah. So we just do call it correlation. Cool. It's pretty cool. These are just scatter plots. Scattering shit. This is just a layout. This is the data. So it's pretty much using the X and Y array right here. This is the range of that data. So there we have up to 150, 7 to 15 here. So he's drawing a line across it. Having these be plot on the graph. This is the line that's drawn across it, I'm pretty sure, yeah. There we go. that line drawn across this markers scatter plot. It's the layout for that. Interesting. They're just cleaning the data, so if there's any nonsense here, I'm pretty sure you can just do drop NA. Drop NA and you can get rid of the stuff. It was drop NA, right? We just do s dot PD. Was it? Where was it from? There was this one. Yeah, so it should be. Oh wait. Is that a thing? So this should be part of this, right? Why is it not detecting that? Now it works, okay. There we go. So pretty much you just drop any empty rows pretty much. It's basically the same shit that we're doing here. There we go. You're just fetching data, map into it, this is JavaScript, plotting it. Yep. What it looks like, scatter plot, and buffer net. Okay, so it seems like so you map onto x-axis, stuff that have x's and stuff that have y's. Inputs with a length. So you use these over here. Cool. Say so epochs are the number of iterations, right? Yeah. Runs the loop, okay. Right, yeah. Usual JavaScript stuff. So this is the training, 70%. 70-30 rule. So that's epochs. Epochs is over here. Model.fit. It's over here. And callbacks over here. And over here. Okay. So we just note this down as well, just as a side note. Training function. And so this is the object, obviously. So we're just gonna extract data, then remove the null values, and sometimes get the so you map through it, filter the filter through the errors, remove the errors. So that's what this does, and the extracted data. So that's what this is. So you just map through it once you have the values. JSON, so it's just usual JS stuff. You render it. Right here. Surface. Cool. Just a way of sort of rendering it. batch is then fed to the model. Shuffling is important to prevent the model getting to do the same data over and over again. Using the same data twice, the model will not be able to generalize the data, give the right output. Shuffling gives a bit of variety of data in each batch. So obviously this is the x-axis, y-axis, and I don't know what this does. Let's just take these. Y-axis labels the length. I'm a little confused here, but it's all good. We just be like ML model, and training wise, okay. So this is just increment in the y-axis, so the x-axis grows parallelly, which is never the case in most cases. Right. So let's say 3, right? And then 2 up, like this. Okay. Okay. So it's basically 3, right? 1, 2, 3, 2 up, 1, 2. So it's just basically this, but like this 3, 2, that's what it means. Okay. So when you combine both of them, combines to a plus b, and the opposite of a is obviously, you know, opposite of a plus is minus in this context. But I'll take a note of that as well. Okay. Grab this down. No. And let me just copy this. Scalar population. Okay, so obviously if I add 1 onto this, I can just add just like this. I can't speak, bro, like my fucking thing is gone. Divide this by 3. Poses a vector with a magnitude and direction. But this is on the physics, isn't it? V minus U over T. I'm pretty sure I remember something like that. V minus U over T. It's like initial velocity minus what? No, added velocity minus initial velocity divided by time taken. Something like that. It's been so long. I remember that from like, I don't know, some class. From somewhere I remember that. velocity, but there's some difference in the velocity and the there's some sort of difference, right? I don't know. Matrices are usually easy stuff. So 1 by 3, 2 by 3, 2 by 3, and like adding this shit is equal. So this is just the opposite, inverse. Because this is negative. How do we multiply shit? Just like you go like this, like this, like this, like this, like this, like this. There we go. And like this, like that, like that, like that, like that, like that, like that. It's the same concept if you're multiplying, but then like when it comes to this is just like I call this like same switch. I mean same switch. The reason why is because in this it does not change. These values do not change, but these do. Like change sides. So it's like same switch, same switch, same switch. And for same switch, same switch. If same, that's why I'm a left-hander, so same switch. So left side says the same. Same switch, same switch, same switch, same switch. Easy. Multiplying like this is annoying, but it's possible. So 1, 2, 3, right? And then, so 1 by 1, 1 by 2, 3 by 3, 1 by 4, 2 by 5, 3 by 6, right? Yeah. 1 by, like that, like that. There we go. Just like that. Easy. Just gonna take a screenshot just in case. Okay. Let's move on. Let's move on. Let's move on. The usual stuff like that, 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 like that. Let's see. Yep. 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 Indeed. Yep. 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 Factorize a matrix. Factorize a matrix. Interesting. Interesting. Okay. Tensors are like the basic way of having these matrices in like arrays, isn't it? Okay, yeah, I mean, this is the n-dimensional arrays, yeah, okay. Reduce this. Why are you doing this now? I don't know, I'm trying to get into this field, man. I don't know, I'm just like going back. Usual stuff. This is adding tensors, so this is the tensor with these arrays. Then this is just adding onto it. Tensor B, boom. Same thing here. Usual stats. Mean, mode, median, usual stuff. Yep. How to calculate them using the math library. Variance, I think I did this already. Standard deviation, we found that already. Distribution is like how far away. It's like the penis, the way I call it. So basically, let me explain this before I look at this penis. All right. So first of all, let me show you guys. Okay. So first of all, if the penis is in the middle, like in the very center, this means that like it's basically like normal distribution, right? But if it's like skewed to like the right side, that means it's like it's negative, and then to the left side it's positive. I don't know, something like that. From the mean, right? So this is how much. So let's say this is the mean. So if it's like right in the middle, that means it's 0, right? So that means there's no. I think it's something like Oh fuck. Standard. No, it was this one. Okay. We copy this. So this is the standard deviation. So this is 0. This is where the penis builds up, and it seems like. So I think negatives are basically like not sure. What's this? So as far as nose hurts. Gotta go through this again. So this is negative and this is a positive skew. Oh wait, that's because these are negative values and these are positive values. That makes sense. 0 is like the very middle. So I think deviation is like how far away are the values compared to the mean value. You know what I mean? Let me try. Different ranges for where we believe the correct answers can be found. The acceptable margin is a matter of judgment to how important the answer is. The more samples we collect, the lower the margin is. Yeah, that's fact. Oh, so this penis is called a bell curve. Skewness describes unexpected values in one trail. Kurtosis describes unexpected values in both trails. Kurtosis, okay. So it's like some God of War shit. The curve gets fucked by God. The Kratos. Kratos fucks the bell curve. That's what it is. Interesting. That's interesting. Okay, so positive kurtosis. Let me just try. Okay, there we go. Positive kurtosis. Ooh. Kratos is the one that shows how screwed up the curve is compared to the normal bell curve, which is the normal penis size. Wait, what? Anyways, I'm sorry. Negatives are basically when you look at the left side, and when you look at the right side, basically positives. It means how far away are the values compared to the mean. So essentially, that's what this person said. I need confirmation on that. So I'm gonna try margin of error. So let me try something here. So copy. Probability. This is obviously easy. How many times is it gonna happen? How many? 1 out of 6. how many times is it gonna be 3, right? 3 in 3/4 at the same time. Six balls. I need to read through this again. Thought it was gonna be easy, but nah. Yeah. Ways to get about outcomes, yeah. Okay. Hold on. Okay, so it seems like so as the sample size increases, the margin of error decreases because the bell curve goes up, I guess. Okay. Hmm. Hmm. Yikes. Above the mean, below the mean. Yep. Okay. Interesting. Okay. Hmm. Okay. Yep. Just add one more step. Get this. right around the mean. Mean, yep. Standard deviation, yep. Okay. Yep. This is pretty cool. This is a simplified list of symbols we mentioned earlier. Let me know if you'd like to add on more details. Any of them. Cool. That's fine. Distribution.
So what is a pullback?